Welcome to ihnani.com. Computer Fundamentals. Introduction to Computers. This is fifth and final video of Computer Fundamentals Part 1. In this video I will cover the remaining generations of computers. For those who have not gone through the previous videos, I would suggest to complete them before going through this video, which will help you in understanding it better. Third generation from 1964 to 1971. Technology, integrated circuits. The development of the integrated circuit was the hallmark of the third generation of computers. Despite the fact that transistors were clearly an improvement over the vacuum tube, they still generated a great deal of heat, which damaged the computer's sensitive internal parts. The quartz rock eliminated this problem. Jack Kilby, an engineer with Texas Instruments, developed the integrated circuit in 1958. The picture shows a typical IC. A typical chip is less than quarter square inches and can contain millions of transistors. Transistors were miniaturized and placed on silicon chips, called semiconductors, which drastically increased the speed and efficiency of computers. The IC combined three electronic components onto a small silicon disk, which was made from quartz. Scientists later managed to fit even more components on a single chip, called a semiconductor. Silicon is a nonmetallic chemical element in the carbon family of elements. Silicon, atomic symbol Si, is the second most abundant element in the Earth's crust, surpassed only by oxygen. Sand and almost all rocks contain silicon combined with oxygen, forming silica. When silicon combines with other elements, such as iron, aluminum or potassium, a silicate is formed. Compounds of silicon also occur in the atmosphere, natural waters, in many plants and in the bodies of some animals. Silicon is the basic material used to make computer chips, transistors, silicon diodes and other electronic circuits and switching devices because its atomic structure makes the element an ideal semiconductor. Silicon is commonly doped, or mixed, with other elements, such as boron, phosphorus and arsenic, to alter its conductive properties. A chip is a small piece of semiconducting material, usually silicon, on which an integrated circuit is embedded. A typical chip is less than quarter square inches and can contain millions of transistors. Computers consist of many chips placed on electronic boards called printed circuit boards. There are different types of chips. For example, CPU chips, also called microprocessors, contain an entire processing unit, whereas memory chips contain blank memory. Semiconductor is a material that is neither a good conductor of electricity like copper, nor a good insulator like rubber. The most common semiconductor materials are silicon and germanium. These materials are then doped to create an excess or lack of electrons. Computer chips, both for CPU and memory, are composed of semiconductor materials. Semiconductors make it possible to miniaturize electronic components, such as transistors. Not only does miniaturization mean that the components take up less space, it also means that they are faster and require less energy. Fairchild Camera and Instrument Corporation built the first standard metal oxide semiconductor product for data processing applications, an 8-bit arithmetic unit and accumulator. The fundamental components of this semiconductor laid the groundwork for the future discovery of the microprocessor in 1971. Another company that took advantage of the third-generation advancements was IBM with the unveiling of the IBM System 360. The company was making a transition from discrete transistors to integrated circuits, and its major source of revenue moved from punched card equipment to electronic computer systems. Instead of punched cards and printouts, users interacted with third-generation computers through keyboards and monitors. Another third-generation development included the use of a computer operating system, which allowed machines to run many different programs at once, with a central program monitoring and coordinating the computer's memory. In 1969, AT&T, Bell Laboratories programmers, Kenneth Thompson, and Dennis Ritchie, developed the Unix operating system, on a spare mini-computer. Unix was the first modern operating system, which provided a sound intermediary between software and hardware. Unix provided the user with the means to allocate resources on the fly, rather than requiring the resources to be allocated at the design stages. The Unix operating system quickly secured a wide following, particularly among engineers and scientists at universities and other computer science organizations. Computers, for the first time, became accessible to a mass audience. Fourth generation from 1971 to the present day. Technology, microprocessors. The microprocessor brought the fourth generation of computers, as thousands of integrated circuits we rebuilt onto a single silicon chip, a chip that contains a CPU. This picture shows the front and back view of the recent and one of the fastest desktop processors. Core i7 from Intel with a feature size of 45 nanometer and maximum speeds of 3.33 GHz. After the invention of the integrated circuit, the next step in the computer design process was to reduce the overall size. Large-scale integration, LSI, could fit hundreds of components onto one chip. By the 1980s, very large-scale integration, VLSI, squeezed hundreds of thousands of components onto a chip. Ultra-large-scale integration, ULSI, increased that number into the millions. The ability to fit so much onto an area about half the size of a US dime helped diminish the size and price of computers. It also increased their power, efficiency and reliability. In the world of personal computers, the terms microprocessor and CPU are used interchangeably. At the heart of all personal computers and most workstations sits a microprocessor. Microprocessors also control the logic of almost all digital devices, from clock radios to fuel injection systems for automobiles. The basic characteristics that differentiate microprocessors are the instruction set, or program, bandwidth and clock speed. Instruction set is the program or set of instructions that the microprocessor can execute. Bandwidth is the number of bits processed in a single instruction, and clock speed is the number of instructions the processor can execute per second. While the bandwidth is calculated in terms of bits, the clock speed is calculated in hertz. The higher the value of bandwidth and clock speed, the more powerful the CPU. The CPU is the brain of the computer. Sometimes referred to simply as the processor or central processor, the CPU is where most calculations take place. In terms of computing power, the CPU is the most important element of a computer system. On large machines, CPUs require one or more printed circuit boards. On personal computers and small workstations, the CPU is housed in a single chip called a microprocessor. Two typical components of a CPU are the arithmetic logic unit, referred to as ALU, which performs arithmetic and logical operations. The control unit, which extracts instructions from memory, decodes and executes them, and calls the ALU when necessary. In third generation, the integrated circuit was manufactured to fit a specific purpose. But now microprocessors are manufactured and then they are programmed to meet any number of demands. What in the first generation filled an entire room was fit into an area about half the size of a US dime. The Intel 4004 chip, developed in 1971, took the integrated circuit one step further by locating all the components of a computer viz. Central processing unit, memory, and input and output controls onto a tiny chip, the microprocessor. Such condensed power allowed everyday people to harness a computer's power. They were no longer developed exclusively for large business or government contracts. By the mid-1970s, computer manufacturers sought to bring computers to general consumers. These mini computers came complete with user-friendly software packages that offered even non-technical users an array of applications, most popularly word processing and spreadsheet programs. Pioneers in this field were Commodore, Radio Shack and Apple computers. In the early 1980s, arcade video games such as Pac-Man and home video game systems such as the Atari 2600 ignited consumer interest for more sophisticated, programmable home computer. In 1981, IBM introduced its personal computer, PC, for use in the home, office and schools. This decade saw an expansion in computer use in all three arenas as clones of the IBM PC made the personal computer even more affordable. The number of PCs in use more than doubled from 2 million in 1981 to 5.5 million in 1982. 10 years later, 65 million PCs were being used. Computers continued their trend toward a smaller size, working their way down, from desktop to laptop computers, to tablets, to smartphones. In direct competition with IBM's PC was Apple's Macintosh line, introduced in 1984. Notable for its user-friendly design, the Macintosh offered an operating system that allowed users to move screen icons instead of typing instructions. Users controlled the screen cursor using a mouse, a device that mimicked the movement of one's hand on the computer screen. Microsoft, the world's dominant operating system maker, first introduced an operating environment named Windows, on November 20, 1985 as an add-on to MS-DOS, in response to the growing interest in graphical user interfaces. Microsoft Windows came to dominate the world's personal computer market, overtaking Macintosh operating system, which had been introduced in 1984. As of October 2010, Windows has approximately more than 90% of the market share. As computers became more widespread in our daily life, new ways to harness their potential developed. As smaller computers became more powerful, they could be linked together, or networked, to share memory space, software, information and communicate with each other. As opposed to a mainframe computer, which was one powerful computer that shared time with many terminals for many applications, networked computers allowed individual computers to form electronic gateways. Using either direct wiring, called a local area network, or telephone lines, these networks could reach enormous proportions. A global web of computer circuitry, the Internet, for example, links computers worldwide into a single network of information. In today's world, even everyday household items such as microwave ovens, television sets, and automobiles with electronic fuel injection incorporated, mobile phones, all have microprocessors. Knowingly or unknowingly today, we are dependent on computers for most of our daily activities. Today, just by bringing down the computers and network of a country, You can bring the entire country down. As I see today, we are not in a position to go back and be independent of the computers. Fifth generation from present and beyond. Technology, artificial intelligence. Fifth generation computing devices, based on artificial intelligence, are still in development, though there are some such as voice recognition, text recognition, motion sensing that are being used today. The use of parallel processing and superconductors is helping to make artificial intelligence a reality. Quantum computation and molecular and nanotechnology will radically change the face of computers in years to come. The goal of fifth-generation computing is to develop devices that respond to natural language input and are capable of learning and self-organization. Artificial intelligence is the branch of computer science concerned with making computers behave like humans. The term was coined in 1956 by John McCarthy at the Massachusetts Institute of Technology. Programming computers to play games. To make decisions in real-life situations. To understand natural human languages. Neural networks were systems that simulate intelligence by attempting to reproduce the types of physical connections that occur in animal brains. Robotics, which is to programming computers to see and hear and react to other sensory stimuli, are all parts of artificial intelligence. In short, artificial intelligence is to program a computer to simulate a human behavior. Currently, no computers exhibit full artificial intelligence. The greatest advances have occurred in the field of games playing. The best computer chess programs are now capable of beating humans. In May 1997, an IBM supercomputer called Deep Blue defeated world chess champion Garry Kasparov in a chess match. In the area of robotics, computers are now widely used in assembly plants, but they are capable only of very limited tasks. Robots have great difficulty identifying objects based on appearance or feel, and they still move and handle objects clumsily. Natural language processing can be of great benefit by allowing people to interact with devices as we could speak to other humans. Unfortunately, this task has proved to be more challenging than initially believed. Some simple translation systems are available, but they are not even close to being as good as human translators. However, in gaming arena, Microsoft has been doing great strides. Kinect for Xbox 360 is a controller-free gaming and entertainment experience for the Xbox 360 video game platform, and may later be supported by PCs via Windows 8 operating system. Based around a webcam-style add-on peripheral for the Xbox 360 console, it enables users to control and interact with the Xbox 360 without the need to touch a game controller, through a natural user interface using gestures and spoken commands. There are several programming languages that are known as AI languages because they are used almost exclusively for AI applications. The two most common are Lisp and Prolog. This video completes the Computer Fundamentals, Part 1. In this series, we cover topics. What is a computer? Characteristics of computers. History of the development of computers. Generations of computers. I hope you have understood these topics and are ready to move on to the next part. We have also provided materials which should help you. In case of any questions, feel free to use the iGnani forum. Also, don't hesitate to go through these videos again. Let others know about iGnani.com, help us in sharing the knowledge.